All right, starting off with the task, the very first task of the semester, right? Something to talk about. We're going to start developing an understanding of quadratic functions and how they work and how to decide whether something is quadratic or not. And they're starting us off with some questions here, and we have to go back and we have to look at what type of form these are. If you need to, refer back to your explicit and recursive equations there on page 3 and 4 to determine this. But my suggestion is pause the video for a minute and see if you can determine the rate of change of these figures here. Okay? A is a little bit different form than what you're used to seeing. If you distribute, you get 3x minus 3. So f of x equals 3x minus 3. What is the rate of change? Well, the short of it is here, hopefully you paused it, 3 is the rate of change all the time. B is a recursive equation because it gives you, it's in that form, and it gives you a beginning value. If you look back, the constant rate of change here is 2, so this is linear. This is linear. C, what is happening in C? Most of you noticed it is adding 3 every time. Okay, so the next figure, here, here, and here, it added 3 from the previous. Here, here, and here, it added 3 from the previous. Here, here, and here, it added 3 from the previous. So plus 3, plus 3, plus 3. That is a linear function. 8 to 1, minus 7. 1 to negative 6, minus 7. Minus 7, minus 7. Linear. It's a linear function. Oh gee, E has to be the one that's different. So I'm going to come down here and my explanation is going to be E is different. My question is to you is why is E different? Well, because it's the only one that's not linear. Well, how do you know? Prove it to me. Okay? You need a complete sentence right here. This is not going to get you anything. In fact, I will give you 0 credit for all of that. 5 to 6, what do I do? Plus 1. 6 to 9, plus 3. 9 to 14, plus 5. 14 to 21, plus 7. 1, 3, 5, 7. If I were to go to the fifth figure, what would it be? It should be plus 9. Okay, so that is a first difference. Not the same. Not going to be linear. Not a common multiple. Not going to be exponential. How about if I go to a second difference? What do I do to 1 to get to 3? Plus 2. 3 to 5. Plus 2. 5 to 7. Plus 2. 7 to 9. Plus 2. See what's going on? Okay, so now my explanation is E is different. Okay, E has a common, what? You continue. You write the sentence. E has a common second difference. E is a difference of 2. All the other ones are linear. You write something there. That's what I'm going to be looking for. So you finish that. Pause it, and then come back when you're done. All right, so now we get into the next thing that we were talking about. Okay? So as it says, cell phones often indicate the strength of a phone signal with a series of bars. The logo below shows how this might look. Question number 1, draw the fifth figure in the sequence. What it wants you to see is it wants you to see, and you can see things differently than I do, but what I see is I see the bottom growing by 1 each time. And I see the previous figure on top of that. So figure 5, what it's asking me to do, number 1, figure 5 is going to have 5 on the bottom. So there's 3, 4, 5. Yeah, sorry, the diagram's a little off there. And then it's going to have 4 on top of that, 3 on top of that. Move down here. Come on. It's going to have 2 on top of that and 1 on top of that. Here's my figure. Right? So 5, 4, 3, 2, 1. The next question says, how many blocks are going to be in figure 10? Well, there are multiple ways of doing this, and in class we talked about several ways to do this, but what some people should recognize is that you're going to have 10 blocks, and then you're going to have 9 blocks, and then you're going to have 8 blocks, and you're going to do all this all the way up to 1 block. Okay? So I can sit there and I can count 10 plus 9 plus 8 all the way to plus 1, right? okay, that's not too bad, right? I even have, some people notice that figure 1 would have 1 block. Figure 2 would have 3, so that's a difference of +2. 3 would have 6, so that's +3. So you could go +4, +5. There's a lot of different ways to do this, so you just keep up with that pattern. Again, the purpose is recognizing patterns. But, all right, so stop and count and see how many you get. 10 + 9 + 8 + 7 + 6 + 5 + 4. I don't want to have to count. I don't want to have to figure that out. In this case, it's not too bad. We said there were 55 blocks. Okay? Let's back that up, because it says it wants us to examine the sequence and come up with a recursive, and then, well, it wants a rule or formula. We're going to come up with an explicit and recursive formula for both of these. Now, the explicit one's going to be a little more difficult. The recursive one, most of that isn't going to be bad. That's going to be f of 1 equals, and f of x equals f of x minus 1, and then some information. Well, f of 1 is the first term. The first term is 1, so I have most of it finished. All I need to do is I need to go ahead and I need to fill in the rest of this here. And if I go back and look at a recursive for a quadratic function, I refer back to this page here, page 5 it was, or 6. I'm going to look and see, oh, it should be something like 2x minus 3 is what that looks like. So that's where that should be. And this better have a square in it somewhere. Well, let's fill in our table and do some other stuff first. So this is going to be figure number, and I'll just use red because it makes it, and this is going to be number of boxes. Now, you should be able to go through and fill this in. Okay, so I'm going to kind of speed through this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 55, 45. Go back up here. 1, 3, 6, 10, 15, 21, 28, 36. And then our differences here. 3, 4, 5, 6, 7, 8, 9, 1, 1, 1, 1, 1, 1, 1. And you should be able to figure this out. Pause, take the time, stop and think about that. I'm serious. Now, what if we graph this? It wants us to graph it. Well, I'm going to graph x's and I'm going to graph y's. What are my x's? My x's are straight out of my table. My x's are my figure number. Okay, so my figures are numbered 1 through 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then what does my y represent? My y represents number of boxes, right? So how do I input my number of boxes here? Do my boxes go by 1, 2, 3, 4, 5? Do I go by 5, 10, 15? I think we went by 10, 20, we skipped. So we went by increments of 5. 30, 40, 50, 60, 70. Again, pause and fill that out if you need to, but I'm going to keep going here for sake of time. Now, the other thing I want to do is I want to plot my values over here. I'm not going to do that for sake of time. You should have that plotted and done as well. But what type of graph is this? It has a second difference. Well, here's my common second difference, which is 1. So that's going to end up being my plus 1x right here. And then maybe I have to fill in that b part right here. Well, the b part is where it crosses the y-axis at. If you pay attention, if you go through here and plot your points and figure it out, you should figure out what this value is. The only other thing I have to do is determine what my exponential function is. Well, how do I determine that? My exponential function is going to be determined off of here. And I'm going to go back and show you this and see if this makes sense to most of us. Remember at the very beginning of the semester, I told you that everything revolved around the basic square of x by x, and where the area is equal to x squared. And that is true. What do we do with that basic square? We might change it, we might add to it, we might subtract from it, we might do whatever. But if you look at these diagrams, at least these first 4, maybe not the first one, maybe not the second one, but the third one and fourth one, it kind of looks like we're taking half of those boxes and we're getting rid of them. Well, what are we really doing? What we're really doing is we're taking this first figure and we're creating another figure and rotating it and basically placing it on top of itself. So now, and I can do the same thing with the first figure. Okay? First figure I created. How did the first figure change? The first figure is still 1 high, but it is 1 plus 1 wide, or 1 by 2. The second figure is 2 high, but it is 2 plus 1 wide. The third figure would be 3 high by 3 plus 1, or 3 by 4. This would be 4 by 5, 5 by 6, and so on. So for any given figure, whatever it is, and I'll use this one as an example. For any given figure, we could take the value of its height, which is n, and multiply that by n plus 1. It's width plus 1 extra row. And that's what's happening. So n times n plus 1. But remember, we took the figure and we put it on top of itself. So what we need to do with that is we need to cut it in half. There is your explicit equation. My explicit equation is 1/2 of the length of my figure, n, times the width of my figure, which is n plus 1, and it's half of that. Now, if I distribute, what do you get? You get 1/2 of n squared. There's where your n squared comes, plus 1/2 n. These are both the same equations. That's tough. Explicit equations are tough, and that's how we deal with it, is the relation of function, y-e-s. Is it discrete or continuous? It's discrete because it counts by 1, 2, 3, 4, 5. You can't have a half a box. It's neither, it's quadratic. The domain for this is going to be 0 to infinity. The range is going to be 0 to infinity as well. Okay, because we're not limited in the number of figures that we keep going. The pattern is increasing, and this is going to have a minimum value since the graph opens up. All right. So there's, if you missed, there's the information for today. I know that's a lot. Ask questions.